One thing about my show is that I always ask for helpers from the audience. So please get ready to help. The first thing I want to talk about is called density. To know the density of something, you must know two things about it. How heavy it is and how much space it takes up. Fortunately, there is a test for density so that you don't have to measure anything. The name of the test is flotation. And here's how it works. Hard-boiled egg, water. I'm going to drop the egg into the water. Can you tell me now if the egg will sink or float? I cannot hear. Yes. Float. Oh, I don't think so. But anyway, we're going to try it. To try it, I need a helper. May I get a helper, please? Miss Earl, please go. Back here, please. One hand. Yes. Everyone look. Look at that, it sinks. The fact that it sinks means that the egg is more dense than water. That's how the test works. What my helper has now is salt water. Same egg, salt water, sink or float.
Float.
You pick up quick on things. Now, see that it's floating, which means that the egg is less dense than salt water. Now I'm going to let you in on a secret. This demo is not just about eggs, it's about us, it's about people. We are like an egg. If any of us fell into fresh water, like a river, we would sink. We are more dense than water. But if we fell into salt water, we would float. Let's give my helper some applause. Boys and girls, what is this? Pepsi. Friends, what is this? Diet Pepsi. Friends, what is it that's put into real Pepsi to make it sweet?
Corn syrup.
I fructose corn syrup, that's true. Now, because I'm not good at long words, anti-disestablishmentarianism, things like that, I'm going to call it sugar. Sugar. Now, the next question is harder because when you answer it, you have to give me a number. How much sugar is in the can? How many grams or how many teaspoons? What was the answer? 26 grams. Someone else answered the local 35. 35.
50.
You have it bracketed now. The answer's on the label. I don't make this up. I make up a lot of things, but not this. Sugar. 41 grams. 41 grams. I think that 26 is an 8-ounce serving size. It's important. This jar has 41 grams of sugar. That's the same as 9 teaspoons. Mother, take that. You look at it, but you don't keep it. I want you to circulate it around the room. The two metal cans are the same, and each can is filled up to the same level. Now at this point I need a helper, and there's a requirement on the helper. No small children. I need a teenager or a grown-up to be my helper. Are you a teenager? That's a little
What's the amount of sugar in a Pepsi?
right here. This gets heavy. Friends. You want to see it? I'm going to start with the real Pepsi. I'm just going to drop the Cokes. Let me say something first. The two metal cans are identical, and each can is filled up to the same level. Now I'm going to start with the real Pepsi. I'm going to drop the can into the pitcher. You tell me now if the can will sink or float. I'm hearing sink.
Barely.
Well, it sank. The fact that it sank means that the can is more dense than water. The two metal, okay, now this is the can of Diet. I'm going to do the same thing with the Diet. Will the Diet sink or float?
Float.
Well, look at that, it floats, which means that the can is less dense than water. Here is my review. The two metal cans are identical, and each can is filled up to the same level. This can has absolutely no sugar in it. It floats. This can, this much sugar.
It'll go.
And it sinks. Let's give my helper some applause. Now, I do not require a helper with this one. I'll do it myself. This is a little novelty. There's a big bowl here, a small bowl here, and the fill tube. Now, all of you can see the red liquid, right? It's called alcohol. Now, what you cannot see is the air that's in here. There is air in here, and here, and here. And then there's the air. That's the important stuff. Now, what I'm going to do is heat the air. The air will get hot, the air pressure will increase, and we will see that the air pressure here does the red liquid. I will heat the air with my hot hands. Are my hands hot? No, my hands are not hot. Please show me how I can make my hands hot, by the way. Friction. This also scrapes the dead skin off my hands. Two things at once. Everyone look. Okay. What's that? Madam, this is the Museum of Science. We do not do magic. Let me continue. My hot hand has heated the air. I didn't boil the liquid, I heated the air. But when I heated the air pressure went up along with the air temperature, which all moved together. And the increased air pressure here pumps the red liquid up to here. And it will stay up here. Surely it went back down, but if I put the heat back on, it goes back up. Go up. Thank you. Kind of like children at the shower. Okay, and obviously I could stay here all afternoon making this go up and down, but I don't want to do that. I want to move on, so I'll just say thank you very much for watching my video. Okay, now I need your cooperation. The museum wants me to count the people who are here, so just stay in your places while I count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'll be right back. My next topic is called acids and bases. It's a two-part topic, acids and bases. There are thousands of acids, thousands of bases, and inside acids look nothing like bases. They're very different. Nevertheless, we study them together. That's because of what they do, not how they look. One acid and one base will seek out each other, and they will react. What that means is they give up their identities. They themselves disappear, but they create new compounds after that. That's a reaction. Acids are really common. You should know that you have an acid in your stomach. Young man, what is the name of the acid in your stomach? Stomach acid. This Pepsi acid, 2 different acids added to it at the center. This morning with breakfast, I had an orange.
May I have your attention, please? With the driver of a gray Silverado truck, license number B9311542, parked on the 3rd floor of the garage. Please return to your vehicle immediately. Your truck is parked illegally.
Again. This morning with breakfast, I had an orange. Orange has citric acid in it. Oranges, lemons, limes, and grapefruit all have citric acid.
May I have your attention, please? With the driver of a white Ford F-250 4x4 King Ranch truck, license number BAO9117. Please return to the 3rd floor of the garage. Your truck is parked illegally.
This is vinegar. Vinegar is used in cooking and cleaning. Vinegar is an acid. Not very strong, 5%, but that's strong enough. Now, the opposite of an acid is a base. Ivory soap. Ivory soap is very common and very safe. This is a weak base. It's almost neutral, but not quite. Ammonia, strong base. Horrible smell. Very careful when you work with ammonia. Arm & Hammer baking soda. Wonderful material. Not expensive. Let me tell you some of the many uses of baking soda. If you have too much stomach acid and it's up here, that's heartburn. And you can treat heartburn with a teaspoon of soda and water. You don't have to go to an ENT specialist and she'll tell you have some rare disease, some $100 medicine for it. If you want to brush your teeth and there's no toothpaste in the house, make your own toothpaste out of this. Kitchen fires, and when your cooking experiment goes disastrously wrong. Do you speak laugh from experience? You have to put that fire out right away. One way to do it is to dump baking soda onto the frying pan. Now, look at the name, baking soda. Here's why it's called baking soda. If you want to bake bread, you have to get bread dough to rise. One way to get bread to rise is to mix a teaspoon of soda into the bread dough. You mix it up and you put the loaf aside. Come back in an hour, and what you'll find is that the loaf has doubled. If it was that high at the beginning, after an hour, it's that high. The baker says that the bread has risen. The chemist explains that the baking soda had a chemical reaction that gave off a gas, and the gas expanded. That's the chemical explanation. The baker says that the bread has risen. They're really both the same thing. When an acid reacts with a base, sometimes we can see the reaction. And I have two examples of that now. And I would like to get a helper. May I get a helper, please? Why don't you come up? Let's get the back here. Vinegar and acid. I will not open the ammonia. If I open the ammonia, you run away. I think I run away. Oh, it's not that bad. It's not going bad. Okay, friends, before the show began, I put some baking soda into this balloon. Oh man, give me the bottle. Please hold it this way. Okay, friends, here's vinegar. It's an acid. Here's baking soda, a base. I will mix the two, and all of us will see the chemical reaction. And you, young man, you tell the people to get hot or cold. Okay, see down here? Bubbles and foam. There was a chemical reaction which gave off a gas, carbon dioxide. The gas formed bubbles. Isn't that what I mentioned earlier? The gas formed bubbles. Eventually, the gas leaves the liquid and makes its way up here. And it blows up the balloon. Young man, is it hotter or colder? He says it's colder. That is not expected. Most chemical reactions give off heat. This one does not. This one absorbs heat. Let's give my helper some applause for him. Friends, what is this? Sometimes I get 10-year-old boys who say, blood. It's tea. This is the kind of tea it is. It's called Celestial Seasonings Red Zinger tea. One of the ingredients in Zinger is orange peel. Orange peel. What did I say earlier about orange? It has citric acid in it. This tea is a little bit on the acid side. Not much, just a little. Now, the other ingredients in the tea are these red flower parts. They go together to form a red vegetable dye that gives this the red color. It is, however, a very strange dye because it does not keep its color. This dye is red in an acid, the way this stuff is. It's not red in a base. Let's find out. Help her. Help her. This girl. She's back here. Friends, this is called a flask. It has a narrow neck so that my helper using 3 fingers can hold. Stand here. Okay, friends, I'm going to pour some tea. And remember, this tea has that dye in it. This dye is perfectly capable of staining or dyeing a white top. You want to go home in a pink top? That's red. It's an acid. Here's ammonia. Ammonia is a strong base, way stronger than the heat. Okay, with the 3 fingers, restore. Friends, as you can see, the color is black. That means 2 things. First, it's really obvious the dye changed color. The other thing is that this is no longer an acid, it's a base. A little bit of ammonia I put in overpowered all the acid in the tea. It just so happened that the dye changed color at the same time. Now I much prefer the red color, so I'm going to bring it back. You stand it back here. This is vinegar. Vinegar is an acid. Let's have a swirl. Okay. It's back being red. It's back being an acid. What I have done is to reverse the chemical reaction. I started with tea, red, and acid, and I added a touch of ammonia, a base, and I got the black color. That's the forward reaction. And just now, I added a touch of vinegar and acid, and I restored the red color. That's the reverse reaction. Friends, I want you to compare the flask with the tea. You will agree the colors are close. Now, what do you think? The liquid in the flask, is it the same as the tea? No, it's not. It's not. What should I do with the liquid in the flask?
Not drink it?
Not drink it.
Yeah.
Pour it out, yes. I should pour it out, and I will pour it out as soon as you give my helper some support. Okay, friends, I'm going to dump this, but I'll be back in 20 seconds with the best demonstration of all. My last topic is called polymers. What's this thing? What's this? Oh, is it? That's what you meant to look. Okay, let me talk about a chain. A chain is a long object. This one's 2 feet long. You make a chain by linking together a large number of these small identical pieces called links. Now, a polymer is kind kind of sort of like a chain, but it exists at the scale of molecules. And I mean is, polymers are too small for us to see. A polymer is itself a molecule, really long, that's made by linking together tens of thousands of other smaller molecules. The small ones are called monomers, and the long one is called a polymer. Polymers are necessary for life. Let me explain. Who here has heard of protein? A couple of you have heard of proteins. Proteins are polymers. They look like this. Repeating units in protein are called amino acids. Amino acids. Your body is chock full of protein. The most famous protein is in your muscles. Well, your muscle operates like other things. They operate in pairs, actually. One to this, one to that. That's a protein, that's a polymer. Young lady, what is the color of your blood? You asked a question. Yes, your blood is red. Your blood is red because it contains a protein called hemoglobin. That makes up your red blood cell, polymer. You look the way you do because of a protein called melanin. Melanin affects the color of your hair, your eyes, and your skin. The more melanin you have, the darker those things are. Consider my lab coat. It's woven from polymer fibers. Young man, can you feel the fabric until the heat component? What fabric is it? Okay, well, I'll give you my answer. They may be the same. This fabric is called cotton. But cotton is a living plant. It's alive. It's also a polymer. Same way with wool. Wool fibers are polymers, but wool is nothing more than the hair of sheep. Hair, skin, fingernails, horns on a bull, hooves on a horse. All of these are living. All of these are polymers. Now let me change directions. In the last 100 years or so, engineers and scientists have manufactured polymers. They've taken some wet chemicals in jars on the shelf and forced the molecules into chains. These are called man-made or synthetic polymers. An example is in the carpet. Nylon. Nylon is a man-made polymer. Acrylic wall paint, man-made polymer. Consider the vinegar bottle. What kind of a bottle is this? The common name is plastic. I don't know if anyone in ordinary conversation would call this a polymer bottle, but that's what it is. It is a polymer. The name of the polymer is polyethylene. Now here's another plastic bottle. Right? Soda bottle, water bottle. This one looks nothing like the vinegar bottle. The vinegar bottle is cloudy, it's see-through. The name of this polymer is PET. Sometimes it's called PET. Rubber, polyisoprene. Now I'm going to try to give you two poly demos. The first one involves this white powder, sodium polyacrylate. That's the last time I'll mention it. Its claim to fame is that it can absorb 800 times its weight in water. You see this? You know what this is? If you were to cut this open, inside you would find soft paper, but you also find a little bit of the white polymer powder. This white polymer powder in here that keeps baby dry. Now, I'd like to show you how one of these works. Yes, I will. May I have a helper, please? That little girl with the heart. That's great, please. You're not shy. Okay, I put just a little bit of powder in. Trust me, it's enough. Well, that's my diaper. What am I missing? I have a volunteer to be the baby? No, I didn't think so. Okay. Sometimes I do. Then we look into that and tell the people what you see. She says she sees white water. Where I come from, we do have white water. That's because we fell over rapids and rocks. Some lady poured out. Look at that. Okay. Babies don't stop with a little bit. Babies keep going. There's one young lady who wants you to count up to 10 out loud, slowly. Loud, much louder. You did it without your help. Okay, let's repeat it. What does it look like? No change, white water. Pour that out. Look at that. Now with this hand, put the finger. Nice shit. Mushy. Okay, friends, that's not white water. It's also not ice. It's also not solid. This is a material called gel. A gel is a suspension of a polymer in water. Some people put gel in their hair, right? Polymer. Who here eats peanut butter and jelly sandwiches? Good. Some of you, not many, some. You do. Like the jelly is a kind of a gel. It's one you can eat. You can't eat this, but you can eat jelly. The polymer in jelly is called pectin. There's a very famous dessert that jiggles when you tilt it.
Jello.
Jello, another gel. Who knows the name of the polymer? Gelatin, yes. Who knows the source of gelatin? Where gelatin comes from?
Ants.
Animals.
Yeah.
You said it right. The source of gelatin is the skin and bones of cows and pigs. When you eat jello, you may be eating bossy, Elsie, or Porky Pig or something like that. Okay, almost finished. This time here, do not turn it upside down. Really hold it. Okay, now friends, you recall I started with a thin layer of powder, and I gradually filled the cup with water. This is kind of thin, but as you can see, a little bit of powder has succeeded in gelling to a whole cup of water. Really powerful stuff. Let's get my helpers in. Now my final poly demo, I'm going to start with one polymer and make a different polymer. The polymer I make is rubber. Here's a rubber ball. It bounces. I'm going to make rubber, and the rubber I make has to bounce like this. Here's a rubber balloon. It stretches. The rubber I make has to do this. I said I would make rubber from another polymer. Here's my starting polymer. What is this? Elmer's glue wall. It is a polymer. I think all glues are polymers and have been since the beginning. But this polymer made in a chemical plant, manufactured. It's called polyvinyl acetate, PVA. Last call for a helper. Come up. much stuff here. Don't like so much stuff around. Let that stay there for a minute. Okay, young man, in a minute, I'm going to start talking to people. When I start talking to people, you start to stir this up. It's not important. Please start to stir.